Welcome to tonight's video on arithmetic series. So we talked last time about arithmetic sequences and what they are, and now we're going to talk about how to find the sum of an arithmetic series. An arithmetic series is just the sum of an arithmetic sequence. So here, if you look, the sum of the first 100 terms as I goes from 1 to 100 of 2i, which is an arithmetic sequence, is, and so they put in the first couple terms for I, 1, 2, and 3, and 4, and then the last three terms of this series are 196, 198, and 200. Something you should notice, if you add the first and the last term, you get 202. If you add the second and the next to last term, you get 202. And if you add the third and the third to last term, sorry, I went too far, it's also 202. And that pattern continues throughout. If you pair the next, like the fourth term and the fourth to last, you would get 202. And that pattern continues all the way throughout. So you are able to make, since there's 100 terms, you could make 50 pairs. So 50 times 202 would give you the sum of 10,100. So let's see if that holds true for another arithmetic series. So here it's from 1 to 1,000 of 3i plus 1. So the first term here would be 4. The second term would be 3 times 2 plus 1 is 7. The third term is 3 times 3 plus 1, which is 10. Then let's do the n term. So let's do the last one, which is 3 times 1,000 plus 1, which is 3,001. Now to find the next to last, I'm going to use the fact that the difference is 3. So I'm going to go backwards. So this is 2,998 and 2,995. So notice if we pair those up, the first and last, it's 3,005. The second and the second to last is also 3,005. And then the third and the third to last is also 3,005. And that pattern will continue for all the pairs. So now, if you have 1,000 terms and you pair them up into groups of 2, that means you're going to have 500 terms. So that means 500 times 3,005 will give you your sum, and that means it is 1,502,500. So in general, that's why to find the sum, if you know the number of terms, which is n, and you know the first term, which is a sub 1, and you know the last term, which we'll call a sub n. If you know those three things, you can find the sum of an arithmetic series by taking the number of terms, dividing it by 2, because that gives you the pairs, and then adding the sum of the first and the last. Adding the first and the last and multiplying it by that. Now, if a sum of an arithmetic series is infinite, all right, there's a few situations that can occur. For example, if, let's say, the difference is greater than 0, it's positive. If you keep adding a positive number to it, then it's going to be infinite. It's just going to keep getting bigger and bigger. If the difference is less than 0, meaning negative, and you keep subtracting, that means it's going to just keep making the sum smaller and smaller and smaller. It's going to go towards negative infinity. But then there's a situation if the difference is 0. Now, if the difference is 0, it'll depend where it will go, depending upon what the first term is. Let's say the first term is also 0. So you just keep adding 0, then the infinite sum would be 0. Now, if the difference is 0, but the first term is positive, well, like let's say, for example, 2, and you just keep adding 2, it's going to be infinite. If the difference is 0, but the first term is negative, then it's going to go towards negative infinity. So those are all the situations that could occur if you have an infinite arithmetic series that you're trying to find the sum of. So for example, in number 1, notice you're adding 4 each time, and it's infinite. So to find the sum, you know, since you're adding 4, it's going to keep getting bigger and bigger. It's just infinite. Number 2, find the sum of the odd numbers between 3 and 1007. Well, remember, to find the sum, we need to know the number of terms, we need to know the first term, and we need to know the last term. Well, here we do know the first term. It's not 3, because remember, it says between, not including. So the first odd number between 3 and 1007 is 5. The last one would be 1005. But we need to know how many terms. So we need to solve by saying, okay, 1005 is equal to 5 plus n minus 1 times the difference. Well, if it's odd numbers, that means you're adding 2. So when we solve this, n plus 3. Now notice, this here is our explicit definition. So that's going to be important when we write our answer for the sum. So keep that in mind. So right now, you subtract 3 to get 1002, and then divide so you get 501. That is the amount of terms. So you're finding the sum of the first 501 terms of this series. And you'll go as I equals 1 to 501 of this definition of 2i plus 3. So when we find the sum, we're going to take the number of terms, divide it by 2, times the sum of the first, which is 5, plus the last, which is 1005. And when you multiply that, you get that it's equal to 253,005. And that's how you would write it. So for number 3, to find the sum of the first 5 terms of 2i plus 5, we know that there are 5 terms. The first term, if we put 1 in, gives us 7. The last term, if we put 5 in, gives us 15. So then we just multiply and we get 55. It says find the sum of the first 12 terms of this arithmetic series. Now in order to find the sum of these 12 terms, we need the explicit definition. Right, so we know the first term is -5. We know n minus 1. And then we need to know, we know the difference is 4. So we have -5 plus 4n minus 4. So it's equal to 4n minus 9. So that is our explicit definition. So the number of terms is 12. The first term was -5, but now we need to know the 12th term. So to find the 12th term, we go 4 times 12 minus 9. So it's equal to 39. And then we multiply. So 6 times 34 gives us 204. Number 5 says find the sum of all positive multiples of 7. Well, all positive multiples of 7 is an infinite amount, and the difference is positive because you're going up by 7, so that means the sum is going to be infinite. Number 6, find the sum of all multiples of 7 between 1036 and 5411 inclusive, meaning it includes those two. So that means our first term is 1036. Our last term is 5,411, but we just don't know how many terms there are. So we can figure that out by taking 5,411, setting equal to 1,036 plus n minus 1 times 7. So we distribute, combine like terms, and remember, this is our explicit definition right here. So then when we subtract 1,029, we get 4,382. And then when you divide by 7, you get 626 equals n. So that means we're finding the sum of the first 626 terms as I equals 1 to 626 of 7n plus 1,029. And that's equal to 626 over 2 times the first term, which in this case, the first term is 1,036, plus the last term, which is 5,411. And when you multiply, you're going to get that it's 2,017,911. All right, we're going to skip 7. Talk about that some other time. Number 8, find an arithmetic sequence where the sum is equal to 0 for the infinite one. Well, remember we talked about that. That's if the difference is 0. So and the first term is 0. So it'd just be 0 all the way infinitely. That would be our sequence. Number 9, algebraically show that these are equal. Well, notice we have a formula for a sub n. So we'll substitute that in and we get a sub 1 plus a sub n is equal to the first term plus n minus 1 times the difference. And then when you combine like terms, you get 2 times the first term plus n minus 1 times the difference. And there you've shown that the left is equal to the right. For number 10, how many terms are being added in this sequence? Well, remember, if you start with 1 and you go to some number d, that means that d terms are being added. Remember, the rule is top minus bottom plus 1. So here, if you start with 5 and you go to k, it's going to be k minus 5 plus 1, so it's k minus 4 terms. So number 11, it says how many terms must be added to give a sum of 400 in the arithmetic sequence? Well, notice that here we know the sum. We know the sum is 400. The number of terms divided by 2 times the first plus the last. But remember, we don't know the last, but we do know the formula for the last, and that's the first term plus n minus 1 times the difference, which is 4. So we'll simplify. So we get 400 equals n over 2 times negative 14 plus 4n. Distribute the n over 2, and you get negative 7n plus 2n squared. So it's a quadratic, so we're going to look to factor. So we get 0 equals 2n squared minus 7n minus 400. And remember, to factor this, you can multiply the first and the last. So the factors are negative 800 that add to negative 7. And they are negative 32 and positive 25. So when we factor, remember that means it's 2n minus 32 because it's 2n squared here, and 2n plus 25 equals 0. And the next rule is that we're going to divide by the common factor in each parenthesis. So here the common factor is 2. Here there isn't one. So then this becomes n minus 16 times 2n plus 25 equals 0. And when you solve, you get n equals 16 and n equals negative 25 halves. Well, notice the term number 1 has to be an integer, and it can't be negative, so negative 25 halves does not work. So that means there are 16 terms in this sequence. So 16 terms must be added for t sub n to have a sum of 400. All right, so the last one, find the two terms of an arithmetic sequence in which the third term is 14. So a sub 3 is 14, and a sub 9 is negative 1. So first we need the difference. So negative 1 minus 14 over 9 minus 3. So it's negative 15 over 6, which is negative 5 halves. And then basically what we would do to find the second term, it's equal to the third term minus the difference. So it's 14 minus negative 5 halves, which means it's a plus. So that's going to be 33 halves. And then the first term is equal to the second term minus the difference. So 33 halves minus negative 5 halves gives you 38 halves, which is 19. So those are the first two terms of that sequence. All right, I hope you enjoyed the video, and we'll talk about the derivation of the formula and some application problems in the next video. Have a good evening.